Hi, and welcome to this iOS video on classes and objects. Now we're going to create a OS X application again, a command line tool, and we'll go to next, and we're going to name this objects, but we're going to make sure instead of using type C, we're going to use type foundation. Foundation refers to the foundation framework, which gives us our Objective-C syntax and coding stuff. So we're going to use type foundation from now on, even if we don't explicitly specify it when we're going into iOS development, which we'll do very soon. We will be using the foundation framework for the rest of this course. Now we're also going to use automatic reference counting. I will talk about reference counting in another video, but for now, just remember to have this checkbox checked. It makes life much simpler for now. So the product name is objects. So if we click next, what we're going to get, and we'll click create, what we're going to get is a main, and notice that this is called main.m now rather than main.c. So we're going to get a main function, and we're going to inside get an auto-release pool block. Now this auto-release pool has to do with automatic reference counting with the checkbox we checked. And of course we have this code here, and we'll get rid of that. Now what the goal is here is to create a class and then to make an object or two out of that class and play with that class's properties and its methods and see what the syntax around that is. So I'm going to go ahead and do that and pause while I create the class, and then we'll look at some syntax. So actually, before I do that, I wanted to show you how to create a new class in the objects application. So I'm just going to click here. I'm right clicking, and then I'm going to say new file, and it will come up, and here I can see the option to create an Objective-C class. So I'm going to click next, and then it says subclass of. For now I want a subclass of NSObject. NSObject is the ultimate root class in Objective-C. Nearly all objects or classes in Objective-C are either direct subclasses or indirect subclasses of NSObject. So I'm going to name my class part. And imagine that we have a manufacturing application or an asset management application, and we need to know some information about each part. So I'm just going to name a class part. A class is a software model that describes a real-world entity. So in the real world, we have parts. They have part numbers, they have sizes, they have quantities, etc. And so class part describes a real-world part. So in object-oriented programming, we are using classes to model a system that exists in the real world. So we click on next, and it'll ask me where I want to save my part, and I'm going to save it here in the objects folder. And when I create that, I have two files that have been created, part.h and part.m. Part.h is going to be the interface for my part. And the syntax here is interface part, this is the class name, colon, and then the class that it is a subclass of. And here we can see that, indeed, it's a subclass of NSObject. So part will inherit all of NSObject's properties and methods that it allows its subclasses to inherit. We'll talk about that a little bit later. Part also has an M file. This is the implementation file for part. So just as in C we have a header file, a .h file, and we would have a C file, in part.h we declare the properties and the methods that will be operating on a part, and in part.m we implement the declaration for the methods. We implement our declared methods in part.m. So again, I'm going to flesh out this part, and we'll be back in just a moment. All right, so now we have a part, and I'm going to take you through the header file and the implementation file. So this is the interface. Notice that we have imported foundation.h. This always comes with an NS object or any subclass or any new class we create. Now, after the interface, I have a block, and this block declares what are called IVARs. IVAR stands for instance variable. In other words, an object is an instance of a class. These are the variables that this object will be able to access and use. So these are IVARs, these are instance variables. As we shall see, in Objective-C there is a much simpler way to do what we're doing here, but we always have to walk before we can run. So I want you to understand what's happening behind the scenes when we go into that later way of doing things, the simpler way of doing things. But I've declared two instance variables for any object of type part, and they are name, which is a char star string, and number, which is an int. Now, I've declared four methods here. Set name will return a void. Now, the method syntax is a little bit unusual, so follow me through here. Set name is the name of the method. It will return a void type, in other words, nothing, and it has one parameter, the part name. So we will take in a char star part name and return nothing. So that's set name. Name is going to return a char star, a string. Set number accepts an int parameter and returns nothing. And number returns an int and has no parameters. So these are method declarations for our class part. Now let's look at the implementation. The implementation imports the interface file, the .h file, the header file, and we see here between the @implementation and @end the definitions for the four methods that we declared in the header file. So set name just sets our property name, our IVAR name, to whatever we send in as the part name. Name just returns whatever is in that IVAR. Set number sets the number IVAR to whatever we pass in as the part number, and number just returns that number. Now, in object-oriented programming, we very often see this. These are called setters and getters, or then setters are sometimes called mutators, and getters are sometimes called accessors, but we can use this setter-getter language. In Objective-C, the setter is by default and usually named set and then the name of the IVAR. So set name where name is capitalized, set number where number is capitalized. Likewise, in Objective-C, our getters are just named the same as the IVAR. So we have getter name and getter number. Getters just return the value. They just get the value back. Setters set the value. So that makes sense, right? So now, how does part get set up? Well, in the simplest way, what we're doing here, part just gets set up, and we make a new part somehow. We'll make those in main.m in here in just a second. But somehow we make a new part, and then for that part, we set a name and we set a number. And we do that using these two setter methods. Later, when we want to find out about the part, we can get the name and we can get the number. So the next step is finding out how these methods get called and how we create a new part in the first place. So let's look at main.m. Now, there are two ways to create a new object. Remember, the class is like the template for an object. and the object is an actual instance of that class. So the part class is just the idea of a part. It has a name and it has a number. But we don't know what that specific part is. The object is a specific instance of a part. So we have two objects being declared here. We have part A and part B. Classes, we always use an uppercase letter at the beginning of a class name. The first character of a class name should be an uppercase letter. So we have part H and part M, and that is uppercase part. We have imported part H, and this of course drag in part M so it's all accessible. So now we declare a new part, and we do this the same way we would declare a C variable. Now remember, objects are pointers, so we declare it as a pointer, and we call this one part A. And we can just send the new message to a part, and this will give us back an object that is a part. Now, what's really happening underneath the scenes here, or behind the scenes, is that we have it is something like this. And we could do it kind of like this. This is a simplification, but what's really going on here is something like this. Part A is being allocated on the heap, so we use memory alloc size of part. That's really what's going on underneath the scene. But our Objective-C syntax gives us this nice messaging syntax, and we can just call new, the new method, on part. There is no new method in part. New is inherited from NSObject. So what this does is it creates a new part, and the part is called part A, and this is an object of type part. Part B is also an object of type part. Here we have first allocated the memory for the part and then initialized it. We've called the init function. Once again, we look through our part H and we don't see any methods named alloc or init. Well, they're there. They are inherited from NSObject. So alloc allocates memory and init sets up our part. So these are two ways, and usually we find that we see this syntax much more often than we'll see the new syntax. But this really does the same thing for now. So think of it that way. I would prefer you in your own code to use the alloc init syntax. It reminds us that we're sending the alloc message to this, and then with that result, we're sending the init message to that. We can group these methods to any, or these message sends to any arbitrary level. It really doesn't matter. So now with part A, we have set its name to widget by calling or sending the set name message to part A, and part B, we've set its name to doodad, doing the same thing. And in part A, we set its number to 37, and part B, we set its number to 14. Okay, what's really going on here? We have one template, part. We have a class, part. We have two objects created from that class, part. But they're separate objects. We could create 943 objects. That's not a hard number, don't worry about that. We could create as many objects of type part as we wanted to. So this is the key to object-oriented programming, is part A has nothing to do with part B. We can't get to part B from part A. We don't know, part A knows nothing about part B, and part B knows nothing about part A, but they are both based on the same class. And this is the key. Remember that, because if you don't remember that, it'll get you into trouble later on. Let's say we have another function, or we have another class that makes a part A. That class's part A will be different from this class's part A because of scoping rules. So they don't connect in any way, but they are both instances of the same class, part. I can't stress that enough. Now, here we have printed out there are whatever number of whatever. So we're sending that getter message to part A. We get the number and we get the name, and that will fill in our format specifiers. Again, for part B's number and part B's name. So when I run this, I'm going to see that there are 37 widgets and there are 14 doodads. Now there's a lot more to classes and objects in Objective-C. The thing I want you to get out of this is our messaging syntax with the square brackets. We send a message to an object and it executes that method. And also the concept of the getter and the setter. Thank you.